Thank you, everybody, and thank you for attending this session. It's a very important session to me because I know a lot of customers are looking to move SAS to the cloud, and I want to let you guys know that SAS 9 runs wonderfully in the cloud, both Amazon and Azure, and it will also run in Google, but we have a lot of experience, people picking up their SAS grid installs and moving them up into the public clouds. But having said that, what I want to be talking to you about is some of the experiences that we've run into. Before I go there, I would like to introduce myself. You guys have all heard that SAS has been around for 50 years. I actually started at SAS in 1982, so in May of 82. So 46 years ago, I started at SAS. It was much smaller than what it is here, and we had a lot of fun, still do have a lot of fun, been supporting SAS 9 for a long time. So one of the things I do is help customers understand the compute resources for running SAS and for setting up their hardware correctly to make sure that they're happy. In doing that, I've had a lot of help with customers to be able to, after the fact, after they've moved on their own. So what I'm going to be explaining to you today has to do with what we have learned over the years as SAS has moved into the public cloud. There's a lot of it's easy button and things along the lines of that. I want to make sure you understand what to look out for and to make sure that you don't run into any of the pitfalls some of our earlier customers did. As a disclaimer, one of the very first things here is the fact that things are always changing in the cloud. So what I'm presenting is as of 2 weeks ago when I put the slide deck together, but they may change. Not as much anymore, but there when I first presented this presentation 10 years ago, it was changing pretty rapidly. I am more than happy to share my slide deck with anybody. I will have a notepad up here. Give me your email address. I'll send you my slide deck and my contact information. I also have a PDF that's available on www.sas.com that has the words that I'll be talking about today in the PDF for you to share. Short and sweet. I don't like long papers. I like to make them short enough that the IT department will read. You know, if I make them more than 5 pages, they won't read. So, but yeah, so that's what we're doing here. So one of the things you need to pay attention to before you get started on your decision is to have an extremely good understanding of the SAS 9 application that you're looking to move into the cloud. What type of SLAs do you have in place? What are all the layers involved? A definition of success criteria. Rarely is the success criteria is the job finished. The job has to finish in the time it finished on-prem, if not faster. So those are some of the definitions that need to be decided. And to have a good understanding of your machine running, and I'm going to call it on-prem instead of on-premise, but of your machine running on-prem, of the compute, the CPU, the memory, I/O throughput, your network, and disk capacity that you need to be able to run things. So this is very important, and I'll spend a little bit more time on that. From a compute cycle, if you were to look at your computer, you're going to see that at certain times of the day, you're probably only running at 20–30% of the CPU. But if you spike, usually 8 o'clock in the morning when everybody starts logging in, or on the weeks where if you're a bank towards the end of a quarter where you're running your regulatory jobs, your compute is needed. So a decision's going to have to be made. Do I get an instance in the cloud to meet my peaks, or do I just go with, and spikes, or do I just go with the average? So there's pros and cons there. The average means maybe 80% of the time you'll be happy, but if you, then at the end of the quarter when you're running those jobs, those guys are not going to be happy. So you need to determine who's going to scream the loudest and give you the most heart pain, and then you go with supporting them. The same is true with memory. I/O throughput, so there's I/O throughput to your persistent files, your SAS data files, your databases. But the most important file system to look into is the SAS work, your temporary SAS data file. You need to make sure that you have enough I/O throughput to be able to get your jobs to finish on a timely fashion there. And then there's the network bandwidth. You know, if you've got multiple machines as part of your SAS tier, if you are accessing data from somewhere else, this, that, and the other, the network is very, very important. So you need to understand what's going on there. These are some performance coming from this. These are some graphs that come if you run the Inmon hardware monitor tool that's available free of charge from IBM. And you can see what I'm talking about with peaks. For the most part, I think that says 10% is what the CPU is, except for at that one period on the right-hand side where it spikes up and uses a lot of CPU time, and then a lot of I/O, the amount of time that disk is being written to or read from. So that's very important to know, to be able to submit with what's going on. So getting a good understanding from your on-prem system before you start even thinking about going into the cloud is important, because you need to have that information to drive what instance type you will need in the public cloud. And a lot of times you have to, when you're looking at the instance type, you need to understand the amount of storage that's going to be used. The number one file system that we have to make sure is as robust and performant as possible is the temporary file system, the SAS work file system. So the temporary file system needs to be, again, as robust as possible to get your jobs done as quickly as possible. When I help customers that are not happy with the performance in the cloud, 9 times out of 10, their SAS work file system is not robust enough. There's a ton of latency there, and we have to go in and look at what we're doing. And it's really important to know just how big that file system needs to be and how fast you need for it to be, because that's going to dictate the instance type you can go with. Some of the Amazon instance types does not have any local drives. You're going to have to go to you're going to have to go to persistent storage, your ST1s or EBS storage within the Amazon, which means you're now going through a network to get to it, and it's going to impact your I/O throughput there. So those are things that are very important to understand. If you are an existing SAS Grid customer, as you know, your grid nodes all connect to a shared file system on-prem. That's very easy to do. You stand up a storage array, you connect all of your machines to that, you're able to do very fast I/O to them. You don't have that same concept in the cloud. There's no ability to put a storage array in the middle and connect all of your machines together, except through NFS. But if you're wanting, like if you had before and you were running on-prem with IBM Spectrum Scale or Red Hat GFS2 on a very robust storage array, that's not available to you in the public cloud. So you need to understand that. You need to understand the throughput to that shared file system so that we can see what the best alternatives are when you move forward. And then there's all kinds of other things that come into play. So I've listed some things here because they have bitten other customers that have moved their SAS to the cloud. SAS, the binaries themselves are in the cloud, but sometimes the client is not. Sometimes the database is not. And in one case, they had authentication somewhere else and not in the cloud, so it caused all kinds of login latency when they move forward. So we're going to come in here now and start talking about the different types of instances. So it's important to know all of that information to be able to help you drive which instance types would be the best for you to go with. And some things to look at is to understand and read all the fine print around an instance type, because they may quote you very fast I/O throughput, but make sure they don't use the word bursting or burst after it, because if that's the case, you will get that very fast I/O throughput for an hour in a 24-hour period, but then the other 23 hours, the I/O throughput may be a quarter of what you got for the first hour. So those are some things to pay attention to. So it's going to be very important that you may have to trade off with the price of an instance in order to make it performant. So if you're going to the cloud because everything's going to be cheaper, I can pretty much guarantee you everything's going to be slower. In working with Amazon, we did a lot of testing. We've got a lot of customers that are up in the Amazon cloud. This is by far, if what you're doing is heavy I/O with SAS, processing large volumes of data, doing analytics, this is, by far is my favorite instance type to use. So what we're doing here is we're looking at the i3EN. These are on their compute tiers. These are their I/O storage ones. You're going to see that there's 12 physical cores. Amazon's going to say that it's a 24 vCPU instance. Those are virtual CPUs. SAS only runs on the physical, so you need to divide that number by 2. So there's 12 physical cores, which is probably more than what you need from a core perspective. But the 192 gigabytes of RAM is very good for SAS 9. And the most important one here are the 2 internal NVMe drives that can be striped together for your SAS work file system. This will give you close to 200 megabytes per second I/O throughput, and that is above what we recommend you go with. For persistent storage, storage that stays around between a reboot of the instance, you have very good I/O throughput to the network, and EBS ST1s is what I generally recommend. The other thing that's important to note here are the 25 gigabit network. You need to be careful when you go and read the instance types because it may say up to 25. That means you're sharing that 25 gigabit network with other instances. If it just says straight 25 gigabit network, it means you're guaranteed that 25 gigabit. So if you're doing things that are sharing data between multiple SAS systems within your SAS grid or your SAS EBI install and or pulling data from an external database, this, that, and the other, it's very important to have a robust network. So this is the instance type I like. A lot of the sales teams get very mad when I share this because they come back with, do you know how expensive it is? I'm like, well, do they want to have it performance or do they want to go with a cheap instance? It's the customer's choice. It's your choice what to do. But if you're unhappy with performance, I'm going to come back and say things along the lines of, you have to make sure that you have it robust enough. And again, I'm more than happy to share this slide deck with anybody. If you're in Azure, one of the main things within Azure is you'll notice the top in the title of the slide, the word constrained. So what you're going to have to do is grab the E32-16DS instance type, which has 32 virtual cores, constrain it down to 16 virtual cores, i.e. turn off half the cores so that we can get the amount of RAM needed that's more than enough RAM for SAS, but also the internal SD drive to be big enough to run with SAS for temporary space, and also to be able to get a dedicated 16 gigabit network card. Again, those numbers are smaller than what we saw in AWS, but for the most part, it's going to be good enough for you to run your SAS jobs there. But the biggest thing here with Azure is constrained. You're going to have to go with a larger instance type and constrain it down to smaller. So those are the big things from that point of view. The next thing to talk about is storage. The persistent SAS data files, temporary, which are usually ephemeral storage, which means if you reboot the instance, it goes away. What the I/O throughput is. Make sure that bursting is not a feature for what you put together. The fourth bullet there, make sure you get enough disk space. The number of times that I've had people put up an instance type and go, oh, it has 2 NVMe drives, this is great. And then I'll ask them when they fill up that file system for SAS work, how big was your SAS work on-prem? And they'll come back and say, Oh, it was like twice the size of what we have here. Well, if you needed twice the size on-prem, you're going to need the same size in the cloud. So it's very important to understand what's going on there. A little bit of discussion here about the AWS storage. AWS has wonderful NVMe drives for temporary ephemeral storage. They disappear on a reboot. Perfectly fine. If you reboot the operating system, you'll never be able to attach to the files that you put in SAS Work anyway, so this is great for the temporary space. EBS, and I, for the life of me, don't remember what elastic something storage, I can't remember. There, you need to pay attention to these. ST1, ST whatever is what we like. It is for fast I/O throughput. SAS, remember, SAS does large block sequential I/O, so it's very important to use that one. There are some other ones out there. The IOX can be used to a degree, but please do not use the cheaper GP or SC storage types because, again, it is available to hold your data, but your mileage will vary, and I don't think you're going to be really happy going 10 miles an hour. You need to understand the I/O throughput needed for each area. And again, watch out for the bursting. I've had a lot of customers that have gone with one of these, did their initial proof of concept, ran it for 30 minutes or so. Everything was hunky-dory. But again, the bursting lasts for the first hour. So when they come back in an hour or two later, all of a sudden performance is worse. And it's because of the bursting feature that you have to make sure is there. More instances for the Azure. Usually the instance do also have ephemeral storage, but those are generally smaller drives. You can use premium storage for persistent storage, the same as the EBS and Amazon. Be very careful to look at the slide or the website that goes with that, because depending on how sometimes you have to go with 2, if not 3 times the amount of space you need to be able to obtain the I/O throughput that you need for that file system. So make sure you read all of the little buttons there. And again, watch out for the bursting. Microsoft, I had them review my slides because, again, I did this presentation, I think, 11 years ago in 2015. They told me about this new offering called Performance Plus that can be put in place to help speed up the I/O throughput to their storage. And then, you know, if you're a SAS Grid customer, we need to talk about the shared file system to use. Again, could you stand up GPFS in the public cloud? Absolutely. It's going to be very expensive. Some of the other things that are being used, I have Lustre here first because that was the main one we used. There's FSx for Lustre from Amazon, which is as a service. You just tell it how much space you need or the throughput you need, and they'll stand it up. Azure has Azure Managed Lustre. And I just spoke to a guy from Duke University that I worked with last year about standing up AML, and he just came back to me and told me that it was the fastest thing he's ever seen. They love it. So that was just some validation of what we've done with that. So there's 2 as-a-service Lustre offerings from the 2 vendors there. You also have FSx for ONTAP. I believe it's coming from NetApp. We've got lots of, Amgen told me they're very, very happy with using that with their SAS Grid up in the Amazon cloud. You have some other offerings here. You have Amazon EFS storage. Please read the fine print. There is a maximum I/O throughput to that storage. It used to be 500 megabytes per second total. And if you're going with a 10-core machine and we recommend 150, those numbers do not equate. So again, it's wonderful for you to use that for your SAS binaries, have them in a shared location between your different machines, but it is not good for SAS data files, especially temporary SAS data files. The I/O throughput will not be enough. We also have NFS is available out there. Again, NFS is great for writing once, reading often, but if you're doing heavy writes to NFS, the NFS file cache doesn't perform nicely, and we have some issues with that. The next thing to talk about is where to place the SaaS components. This is very important, and it's been one of the places where we've done the most work with customers. SaaS clients was recently working with a customer that moved their SaaS 9 into the Google Cloud, but left their DI Studio customers on desktops on-prem, and some of those were also via at-home networks. And with DI Studio, you do some things and you transfer large volumes of data across the network. Well, going into Google, there was a maximum I/O throughput into the Google network, and it didn't handle it very well. What we ended up having to do is stand up a server inside of Google near their SaaS servers to run the DI Studio client. That way we don't go through the WAN, we don't go through the firewalls, everything comes inside and everything's running wonderfully there. So those are some things to think about. Storage, source data to be used. Oh, this has been a fun one of mine here recently. Customer moved SaaS 9 into the cloud, into the Amazon cloud, but they left their 4 databases on-prem. So they wanted to know why every SaaS job they ran extracts data from their databases, and they wanted to know why things were running 3, 4, 5 times slower. We looked at their queries. We noticed that all the time was being spent fetching data across the network into the cloud. So we had to talk to them about that. They put the cart before the horse. They moved the software to the cloud before moving the data to the cloud. And so therefore they took a hit. They were wanting to know what we could do to speed it up. And I can't make the network faster. Third-party tools. One of the big customers we dealt with did a bunch of testing after they moved SaaS up into the cloud. Everything worked fine. And then they turned it production. And at that point in time, they were using local authentication when it was first in the cloud for the testing. When they went production, they started using their LDAP, which was still in San Francisco. And they were running SaaS in the Midwest. So every time anyone went to log in, they had to authenticate all the way to San Francisco and come back. Once we got them to move their LDAP inside the cloud, it ran fast again. So there are lots of little things to talk about there. High availability is the other one that we can talk about. And I'm happy to take that offline with anyone that might want to talk about it. Being able to keep your data in sync across data center, across zones within that is something you need to be careful about. But it is able to do the high availability. We have a lot of customers that still run when they're running SaaS on premise, they had a clustered metadata server together to be able to make it highly available. They had clustered mid-tiers. And that was because if a machine went down on-prem, it would take a while, maybe days, to get a new machine up and going. When you go up into the public cloud, they guarantee you a machine 99.9999. So you don't really need to worry about it going down. You're going to get something pretty much instantaneously back up. So having clusters, having additional networking, talking between the different areas within the cloud is something to think about. You don't necessarily need it the way you did when you were on-prem. So a lot of the questions coming on here, some scenarios, I talk about some of the scenarios here. A lot of the time what we end up having is the client pieces are still on-prem, but they're running SaaS in a public cloud somewhere, and it's very long, it's far away, so we need to be able to pay attention to that, where it's at. We need to make sure that you understand with the WAN, their firewalls. One of the new things that's coming up when you're going into the clouds is they're doing all kinds of security scans now. Sentinel, Dynatrace, all of those things in place there. Kind of think of them as Norton antivirus that you have on your PC that scans any file that you bring in. So if you're pushing data, if your client pushes data up into the cloud or pulls it back from the cloud, it's going to go through these security scans. And anytime they go through those security scans, it's going to impact the performance of your SaaS jobs. So those are some things you may need to turn off. Again, these are on by default when you go up into the public cloud because everyone's worried about security. You also don't need to have them going between SaaS servers, between your mid-tier SaaS server and your SaaS compute tier. You don't need to be scanning the communications between the two of those. Turning that stuff off is something to look into. This one was also an example of where the source data was in Texas, but they were actually running SaaS Grid in Virginia. So just some examples of just showing graphically or visually how all of this was. And actually their users were physically up in the northwest of the United States. So it was quite entertaining going there. So I've gone through this pretty quickly. This presentation was originally a 20-minute presentation, so I think I've met my time frame for that. But again, it's just the main thing to be able to do is for you to understand completely what the workload is and expect the SLAs. And be able to make sure you have in place what's going on. When you go to stand up your instances within Amazon and you set up the persistent and the temporary SaaS data files, we have tools that can be run prior to installing SaaS to let you know what the I/O throughput is to those file systems so that you can make sure that you are using the correct instance with the robust enough I/O throughput to the machines, to the storage, and be able to do that before you install SaaS, before you copy over your terabytes of data into the cloud to run. So we have a lot of information here to be able to help you with that, to look at it. If you're running Red Hat, we have papers that talk about how to set up Red Hat. You'll set up the operating system the same way you did on premise. All of the tuning guidelines that you do will be the same in the cloud as they were on-prem. So limit your access of your data outside of the public cloud. Again, I believe you're able to push data into the cloud, no problem. But if your data source is in the public cloud and you're trying to pull it out, sometimes there's a charge for that. When you're using SaaS Access, when you're running SaaS in the public cloud, but you may be going after Snowflake or Salesforce or Google BigQuery or the new version of Teradata that's in the cloud, remember that even though they are also in the cloud, they're not in the same region that you are in. They may not be in the same data center that you are in. So you can you treat that as if it's on-prem. It's through a WAN going on there. There's a link here towards the bottom that talks about public cloud tuning guidelines. In there, I go into more specifics, or actually my colleagues at Amazon and Azure have gone into more details of exactly what things to tune, what settings to do. For Azure, you'll need to turn on accelerated networks. You'll also need to make sure you're in the same you're in the same region and proximity group, availability zone. They use different terminology. Everything's together. That not only applies to every instance you're running SaaS on, but make sure those NVMEs that you attach to your Amazon instance is in the same availability proximity group. You are not guaranteed that that NVMe is in the same physical hardware as your CPUs, unless you click and make sure that is the case. Instance types, storage types are changing, not as often as when I first wrote this paper, but they are still changing. And make sure that anytime we've come across anything very substantial when it comes to this type of instances and how SaaS runs in the public cloud, we will post it to the SaaS communities, the administration and deployment channel there. So that is my conclusion, and I'm happy to entertain any questions.
All right, before we get started with Q&A, Margaret has published a companion paper Important Performance Considerations When Moving SaaS to a Public Cloud. This paper is available in the app. So if you go into the app and you navigate to her talk, open up that talk at the bottom, you will see an attachment, and that PDF of her companion paper will be there.
So it's in the app, it's not part of GitHub?
I don't know if you push it to GitHub. This is what I'm seeing.
I did not push it to GitHub, it's part of the app, okay, got it.
Yep, so it is on the SaaS Events app. Now to the Q&A. You had a question, didn't you, sir?
Hi, Margaret. Thank you for doing this for us. I just wanted to get a clarification. You mentioned the DI Studio, because of its data issues, required that it be pushed up there. Any other issues with the clients? I'm thinking like all the SaaS EG users and even the add-in for Microsoft people.
So it depends on what they're doing with things. We're running into a problem with a customer right now using EG, and they're pushing some code and doing a view table. Again, that pulls data back across. So anytime you have anything like that that's going to be transferring data back and forth across, anything other than a small PDF file, you need to pay attention to that because you've got the network between point A and point B. For the DI Studio users, we found that if they were running from their corporate network, they were fine. But the guy that was running across his VPN over a dial-up line was not getting the I/O throughput he needed, and it was timing out. So just understanding that.
Thank you.
This is Sampath. So I support for the CMS. We manage the infrastructure for them. We moved to AWS Cloud about 5 years back. We run into 9.4 grid with 11 nodes. We use this instance type, what I think pretty much what you mentioned here. The first question I have is the NVMe storage, which comes, the instance type, there are two NVMe's comes with, each one is 7.6, around 7 terabytes. So my question is, there are SaaS utility, SaaS util, and SaaS work, right? So do you think that keeping a separate SaaS util and SaaS work would be a better option, or keeping together one?
Stripe those two NVMe's together, and keeping SaaS util on the same as SaaS work is what you need to do.
Okay, still we get the same result even if you have, okay.
We only use util when you're doing a sort. So it all depends on how heavily you're using sorts and things like that. But if you need the 200 megabytes per physical core I/O throughput, you are going to have to stripe those two NVMe's together.
Okay. And my second question is, we use the FSx Lustre. So one of the expensive storage on the AWS. We store in the data in the compressed mode. So even though it's a 50 terabytes, but the actual storage is about 500 terabytes, what we store on the FSx. So do you recommend to use the SaaS work for FSx or just local? Because FSx is a shared file system, right?
Right. That would be a very good exercise to try. I can get you the Rail I/O test script. Run it against your NVMe, run it against your FSx. If you're getting the I/O throughput in FSx for Lustre that you're seeing with your current NVMe's, moving SaaS work there will be fine. But you need to be careful because it may end up costing you more money. You're going to have a bigger FSx. You're going to want to have a separate FSx for Lustre for your persistent data and your temporary space. And you may only want to allow certain users to use the FSx for Lustre, and the ones that need the fastest I/O throughput, you could put on whichever of the two file systems is faster.
Okay. Yeah. And we use for the client, we deployed on the Azure side. So our clients through VM and Citrix with the people use.
Yep.
So one of the challenging what we're having is the user to upload the files into the through Citrix and through on the SaaS. What would be the better options to any other alternate solutions that the users can upload?
I cannot think of anything off the top of my head, but yeah.
Okay. And for high availability, probably I'll reach out to separately on that.
Okay.
But that's another challenging what we are having. So we couldn't. So right now we stand up only in one availability zone because of SaaS work and everything is in one space, and a lot of challenges with that. Thank you.
Yeah. That would be for all I/O to that core. Yeah, yeah. And again, it'll depend on what you're doing. I'm used to working with large banks that need to go through petabytes of data in a quick period of time frame. So I gave you a very large number. If you're a pharmaceutical and you've got smaller volumes of data, you might be perfectly happy with getting by with 100. This is why I'm saying you need to test what you have on-prem to see what your I/O throughput is on-prem today. Poll the users, are they happy? If so, that's all you need to stand up in the cloud. Don't just sit here and say, Margaret said I need this. No, look at what you're doing. I've dealt with some customers that needed 300 megabytes per second I/O throughput per physical core to go through their regulatory jobs in the 24 hours they had to get them done in. I've dealt with pharmaceuticals that can get by with 100 megabytes per physical core. You need to understand your SaaS users. You need to poll your existing hardware.
I have one question, Margaret, for you. This is related to the SaaS work. So in our current infrastructure here at Optum, we do have SaaS work where we have RAID 5 configuration. So we did testing last 2 years back, RAID 0 versus RAID 5. Then RAID 5 came out to be very nice in terms of the performance. So if we ever plan to go onto cloud on Azure, so for the SaaS work, what kind of RAID settings will be a possibility in the cloud? That's my question.
So it's going to depend on what Azure instance you go with. As you saw, that one Azure instance I listed there had a single drive. No need to do RAID, it's a single drive. If you are going to Amazon with the 2 drives, I'm going to say RAID 0 so that you stripe them together and use the full thing. If you try to do RAID 5 on 2 drives, it doesn't make sense. In fact, I think RAID 5 requires, Tom, RAID 5 would need at least 4 drives to do, right? Yeah, you can't do RAID 5 on 2 drives. So it'll depend on what the instance has in place as to what RAID to go with.
Thank you.
You're making me work for it.
One other question I have, sir. So we tried all the different kind of stories in the AWS cloud. So one of the challenging what we had was Linux ACLs. We use Linux ACLs to maintain the security on the Linux level. We only found the only AWS Lustre is the only one is supporting. Do you have any other recommendations other than, because it's very expensive, the customer is kind of complaining about the cost of the Lustre. So do you have any other storage which will support the Linux ACLs that can meet to the SaaS needs for shared file system?
For shared file system in Amazon or where?
Amazon.
So Amazon, my number 1 pick is FSX for Lustre, but they do have FSX for ONTAP, which is cheaper than Lustre. And you can get I/O throughput there. You can always just stay with NFS, but you're not going to be happy with performance. It all.
Yeah,
I mean,
it's always-
so I was told many years ago, and it may have been by Tom many years ago, that when you go to look at storage, there's 3 things. You want it to be reliable, you want it to be performant, and you want it to be cheap. Unfortunately, you get 2. So reliable is a given. You needed a reliable. So you now have a choice between cheap and performant. It's your choice.
But
So-
NFS also has a problem with the number of groups, right? We have 160 projects, so the groups doesn't work. anyway.
That is a very good point there. You also need to, when you look at the shared file systems, anywhere you're putting up a shared file system, what type of groups, security information, this, that, and the other, and make sure that shared file system supports how you're using the software, so,
Yeah, okay.
yeah.
So Lustre is the better one to go.
That's the one that, again, I don't have a budget. I like driving Lamborghinis, so Sorry.
Thank you.
All right, I will be headed back down to the hub. Come and see me.
You're at the SAS9 booth?
SAS9 booth, yes, all the way in the back near the swag. So,
All right, let's give Margaret a round of applause.